Hi there everyone, and welcome to this video on the state design pattern in C#. It's a pattern that likes having an object do its own thing. So what does this pattern do? The state design pattern allows an object to maintain its own internal state. You can think of states being very similar to strategies that you would have in the strategy design pattern. The only difference is, in the strategy design pattern, you have external entities that swap strategies in and out for an object. With the state design pattern, the object can switch its own states automatically. Therefore, this object seems to be changing its own state automatically at runtime. Similar to the strategy pattern, the various states that the object can have are all represented by different classes. So let's take a look at the UML class diagram for the state design pattern. The first object type that we'll take a look at is called state base. Now the state base serves as the base for all of the various kinds of states which an entity might find itself in. Then we have the context. The context in the state pattern is the name of the entity of which the states are interchangeable. You will see that the context has an object of type state base. You'll also see that state base has an object of type context. So these two are fairly tightly coupled. Then lastly, we have various concrete states that depend on state base. These are the actual concrete states that the context might find itself in. Now in this diagram, there are only two states, but an entity, in this case the context, might find itself in 50 different states. There is no limit to the number of states that you can apply to a context. So let's have a look at an example of the state design pattern. We will base this example on your average house cat. Your average house cat on a normal day has three main states, namely sleeping, eating, and a state of silent contemplation in which it considers to take over the world. During the course of the day, the house cat might move between these states. So when the house cat is sleeping, someone might provide it with food. It then traverses over into the eating state. Once it has finished eating, if the food was enough, the house cat might traverse back into the sleeping state. If the food was not enough, the house cat might proceed to the contemplation state. Once the house cat has completed his plan for world domination, he will probably revert to the sleeping state. This kind of diagram, where circles are used to indicate states and lines indicate the means with which to traverse between states, also known as actions, is called a state transition diagram. A state transition diagram provides an overview of a system and all of the states and actions involved in that system. If you design it completely, such a state diagram would actually be representative of a finite state machine, since all of the states involved in this specific scenario would be represented, and all of the actions for moving between the states would also be represented. the next step would be to take this state transition diagram and convert it into a UML class diagram. What we have to remember when doing this is that we have various class types and you have methods. So we have to consider what is going to become a method and what is going to become a class. Let's have a look at the UML class diagram for our cat example. Firstly, you will see this diagram differs slightly from the previous one. Specifically, there are more classes, and secondly, they are named slightly differently. Firstly, our context is now called cat, since the cat is going to be the entity that changes its state automatically. State base has now become cat state, and the two concrete states that we had has now become three concrete states, but they are named according to the states that we found the cat in. So either sleeping, contemplation, or eating. So the cat can be either in an eating, sleeping, or contemplating state. So let's have a look at our cat state class. You will notice that the cat state still has a reference to a context, but in this case, the context is an object of type cat. Our state base also has three methods. The first one, getSfed, is going to be used whenever we need to have our cat traverse from the sleeping to the eating state. So if you refer back to the state transition diagram, this method would be the one that gets called whenever the underling feeds the cat. We need to provide this method with parameters, and the parameters is an amount of food received by the cat, and also an amount with which the cat would actually be happy with. This is important because our next method, bowlEmpty, is going to get called whenever our cat is going to traverse out of the eating state. Whenever the cat traverses out of the eating state, he can either traverse to the contemplating or contemplation state. You will notice that in this diagram, the contemplation state, which was on the state transition diagram, has been renamed to the contemplating state. That's just so it fits a little bit better with the names of all the other states, but it doesn't really make a difference. Now, in order to decide which of these states to traverse to, there needs to be a comparison between the amount that the cat ate and the amount that the cat would actually be happy with. So if the amount that the cat would be happy with is more than the amount actually received, then the bowlEmpty method needs to change the state of the cat to the contemplating state. But if the cat is happy with the amount of food received, the cat needs to be transitioned over to the sleeping state. Then lastly, there is another action in the state transition diagram for moving from the contemplating state to the sleeping state, and that happens when the cat has completed his plan for world domination. And in this case, we have created a method called worldBeware, which fits that purpose. So let's now take a look at the implementation of the cat state. Remember that this pattern uses the cat state as an abstract basis for inheritance. So the cat state that we are going to create is going to be an abstract class. All code created for this video has been written using Microsoft Visual Studio. Microsoft Visual Studio is a one-stop IDE that allows you to write better code faster. Its IntelliSense provides for AI assistant development on Windows and Mac platforms, and it allows for a multi-platform development process. So the cat state class is a class that has been declared abstract. In other words, we can provide or create no concrete implementations of this specific class, only of its derived classes. We provide a field in which we can store a reference to a cat object. You will notice that this field has been declared as protected. There are various versions of the state design pattern. It is not always necessary to have a reference to the context, which is the cat in this case, in your base class. You can store the reference either in your derived classes, or alternatively, it's also possible not to store the reference at all. In some cases, some versions of the pattern do this. So that means that every time one of the methods on a state is called, the context is passed through to it. That's a viable way of doing it if you do not want to save the context all the time. So let's stick to our version for now. Let's declare this context in the base class. The reason it was declared as protected is so that any class that derives from cat state would have access to this specific cat. Cat state also is a constructor in which the cat object is passed through. And then we have three methods. These correspond to the three methods or actions of the state transition diagram, namely the getSfed method, bowlEmpty, and worldBeware. You will notice that all three of these methods have been declared virtual. Declaring them as virtual allows us to provide dummy implementations or empty implementations of these specific methods. You could also have declared them abstract. I will mention this again later, but remember that declaring them abstract would then mean that all of your derived classes have to provide an implementation of the method. That is also an accepted version of the state design pattern, because again, remember, the design pattern tells us what the main entities or classes are. It doesn't specifically tell us what the individual methods should do or how they should be implemented. So next, let's take a look at the actual cat. So remember that the cat is now our context. So just as with the context had to have a reference to the state base, so too does the cat need a reference to a cat state. A cat can have only one state at a given time for this version of the state design pattern. So whenever the cat changes state, the value saved in that cat state field is going to change. We also added an extra field so that we can initialize a cat with a certain amount of food with which it's happy. Because remember, not all cats are happy with the same amount of food. The class would have a constructor, and this was done just to show you that the implementation of a design pattern is not directly tied with the theoretical version of the pattern. That means we can probably add our own methods and change the constructor a little bit, but as long as the links and connections between the different entities in the pattern remain intact, we can still say that we are implementing the state design pattern. So in this case, the constructor receives a type, so it's going to tell us what kind of state the cat is currently in. And this is important because whenever we create an entity in the state design pattern, we need to be able to tell that entity what is its initial state. From there onwards, that entity will be able to traverse states automatically, but we need to at least tell it where to start from. And then, because every cat can be happy with a different amount of food, we're also going to initialize it with a specific amount of food. We also then have three methods: one for receive food, one for finish eating, and another one for completed plan. So the idea behind the state design pattern is we need methods on our context, which in this case is the cat, which is going to be used to call our state traversals. So in other words, when we receive food, we want to call a method on the current state of the cat that says the cat is being fed. So with receive food, we would call the method gets fed. When the cat is finished eating, we would call the method bowl empty on the current state of the cat. And then lastly, when the cat has completed its plan for world domination, we would call the method world beware on the current state of the cat. So let's go and implement the cat and see what this looks like. Let's look at the cat class. The cat class, you will notice firstly, it has a cat state field. And in this cat state field, we will always be saving the current state of the cat. We also have this private field to save the amount of food with which the cat would be happy. In our constructor, we receive two things. We receive the initial state of the cat, as well as the amount of food that it would be happy with. Now you'll notice that the cat receives a type. It does not receive a specific state. The reason for this is, you will remember that when we declared our cat state, the cat state needs to receive a reference to a specific cat. Now unfortunately, in order for us to do that, the cat needs to already exist. So by that logic, when we create this cat, we can only create states after the cat was created. So we need to find another way to create the initial state of the cat, because only after this constructor has been called would the cat object actually exist. So to get around this, instead of passing through an already created state, the constructor receives a type. So in this type, it would tell us whether we need to create a state of sleeping, a state of eating, or a state of contemplating. So this allows us to test, is this state one of sleeping? If it is, then we create the initial state of the cat as a sleeping state and pass through a reference of the cat itself, because the current cat is actually going to be serving as the context. We also perform similar tests for eating and for contemplating. You will see for eating, since eating needs to be initialized with a certain amount of food received. In this case, the cat didn't receive any food, so as a dummy value, it's just initialized to 0. So after the initial state has been selected, we output a message saying that His Majesty the cat is currently in a specific state. So again, this is not really necessary for the pattern, but you will notice that I added it to all of the methods. The reason for this is so that when we run this, let's call it a cat simulator, we can see the various states through which the cat goes. And then lastly, you will notice that the food amount is initialized with the value received. As mentioned on the UML diagram, we have three methods: receive food, finish eating, and completed plan. And whenever we receive food, you will notice that we call a method on current state. Now this is going to happen for every single one of the actions. Basically, when an action occurs, it needs to call a specific method on a state. On which state does it call it? On the state that is currently saved for this cat. Now what makes this design pattern so interesting is that we basically don't know what the current state of the cat is. So in other words, gets fed would yield a different result depending on what value is saved in current state. So that could also result in instances where the cat might currently be in a state where calling gets fed has absolutely no effect. Because if you think about it, if a cat is in the contemplating state, if you refer back to the state transition diagram, if the cat is in the contemplating state and someone calls gets fed, there is no action or line in the diagram that supports that action. So in other words, nothing should happen. Or in some versions of the pattern, an error message might be displayed. Now in this case, we align the method receive food. You'll notice that we receive a certain amount. We align that with the method gets fed. Finish eating calls bowl empty on whichever state is currently saved. And then completed plan calls world beware on whichever state is currently saved. So you will notice that the last thing we are doing is we are implementing the actual states. Because of the way that this design pattern works, we can actually function initially just by creating the cat and the cat state, because the cat state serves as a basis for abstraction and for inheritance. We can build our initial system without providing any concrete states. Obviously, not much will happen when we run this program, but we can actually build it without having any concrete states pre-built. With that being said, our next step is to implement our three states: the eating state, the contemplating state, and the sleeping state. Now, in this class diagram, you will notice that all three of the methods in the base class are present in each of these derived classes. It all depends on how you implement it. You can implement it where we do not declare the methods virtual, as we did in our cat state, which would mean if we declare it to be abstract, say for instance, then each and every single state would need to provide its own implementation. Now, since not all methods are applicable to all states, it just makes it a little bit simpler to provide sort of a catch-all implementation by means of virtual in the base class. But if you want to provide, say for instance, error messages or informative messages for every single method for every single state, there's nothing that stands in your way of doing that. For this example, however, we are only going to implement the methods that we actually need to be able to traverse between the various states. So let's go and take a look at what are the methods that we actually need to implement in these various states. Let's first have a look at the sleeping state. Now, the basic construction of each of these states will be the same. We need to make sure that they inherit cat state, and then secondly, that their constructor initializes our base class. If you recall, cat state expects to receive an object of type cat. So we need to ensure that our derived classes initialize the base class with a cat. Then for each of our states, we will simply go and override the base class method that it needs to implement. So in this case, when we are in the sleeping state, the only possible thing that can happen is the cat could get fed. So in other words, we can have this method receive an amount and an amount that the cat would be happy with, and then just again to show that something is happening, the cat would say that his tribute has arrived. So in other words, his underlings have performed, and then we need to change the state. So if you recall from the state transition diagram, when a cat is in the sleeping state, when the underling provides it with food, it needs to traverse to the eating state. So in this case, we will say that the current state of the handle, which is the cat, which is saved in the base class, is now going to change to a new state of eating. But all of our states, when we initialize them in the constructor, they require a reference to a cat or a cat parameter. You'll see it's the same for all of them. So in order for us to call the next state or create the next state, we need to pass through a reference to the cat that is saved in the base class. And then we also pass through any other parameters that happen to be there or happen to be required. In the eating state, we then receive those parameters in the constructor. We initialize the base class with the cat, and then we save the values over here. So this should also show you that all of the states do not need to be exactly the same. Individual states can do things slightly differently to other states if it is required for them to fulfill their function. So the reason we save these values, remember, when the cat traverses to the eating stage, it's not to say that it will automatically or immediately traverse to its next state, because the cat is now slowly eating its food. It's only when it needs to traverse to the next state that it will actually need to compare these two values to one another. And that happens on the bowl empty method. So in the bowl empty methods, the amount and the amount that the cat would be happy with is compared. If the cat is happy with the amount, in other words, it's equal to or greater than the amount that it would be happy with, we change the cat state to sleeping. Otherwise, the cat state is changed to contemplating. And then lastly, we have the contemplating state. Again, similar constructor to the other states, also inherits from cat state. And the only method that it needs to implement is the world beware method. This method is called when the cat completes his plan, and the only state that the cat can move to from this state is back to the sleeping state. With all of these classes complete, we now need to write a main program to actually simulate this cat. So for this main program, all we're doing is we're creating a cat called Lord of the House. The cat is going to initially be in the sleeping state, so we're passing through a type of sleeping, and then we decide that the amount that the cat would be happy with is 10, whatever that might mean. Then we go through all of the different actions. So we are going to attempt to give the cat some food, and then we'll call its receive food method. Then we will check if he's finished eating, and we'll call the finish eating method. And then lastly, we'll call completed plan. Now this should show us just initially how the cat traverses through its states. You'll see this section of code is a bit longer, and what this does is it tries to access some of the states out of sequence. So in theory, some of these methods might not do anything basically when they are called, because they will only work if the cat is actually in the correct state when a specific action is called. And then lastly, this is another example of calling the states in the correct sequence. The only difference is the top correct sequence, the cat receives enough food. In this bottom sequence, the cat receives less than enough food. So in other words, the cat should go into his contemplation or contemplating state. Once all of this is done, we'll just see a message on screen that says that the simulation is complete. So let's run this and see what our cat does. So as you can see, initially the cat is in the sleeping state. We then attempt to serve the cat some food. He seems to be happy. His underling has brought his tribute. The cat is then in the eating state. Once the cat has finished eating, we are going to try and determine if the cat has finished eating. The feast was seemingly acceptable, so bring the royal cushion. And then His Majesty traverses to the sleeping state because the food was enough. Then you'll remember we ran a few tests with running things out of sequence. So we're trying to figure out whether His Majesty is contemplating, whether he's in thought. We try and do that 2 times, but both times it simply says His Majesty is sleeping. We then check if he has finished eating, but he isn't currently eating. He is sleeping. So next up we try and feed him again. So he says, great, my tribute has arrived, and he traverses to the eating state. We then ask again if His Majesty is in thought, but he's still eating. We check then if he's finished eating, and he will decide that he is happy with the food. We can bring his cushion, and he can go to sleep. So now in this last section, we are going to test what happens if we feed His Majesty, the cat, too little food. So lastly, we serve the cat some food. The cat then traverses to the eating state. We check if His Majesty is happy with this food, but unfortunately, it seems that the food was not enough. So our lack of preparation has doomed all mankind. The cat then goes into the contemplating or contemplation state, and we check again if His Majesty is still in thought. The cat has completed his plan, but before starting world domination, he first needs to take a nap. And the cat ends its final state as sleeping. Well, ladies and gentlemen, that is it for the state design pattern in C#. If you found this video helpful, please click on the like button. If you want to see more videos like this and be notified when we publish them, please click on that subscribe button. Happy coding!